Welcome to RK Tutorials. Solutions to Engineering Mechanics by S. Timoshenko, D.H. Young, J.V. Rao and Sukumar Pati. In this tutorial, we will discuss problem set 2.3, problem number 2.37. A ball of weight W is suspended from a string of length L and is pulled by a horizontal force Q. The weight is displaced by a distance d from the vertical position as shown in the figure. Find the angle alpha, force Q required and the tension S in the string in the displaced position if the ball is in equilibrium. That means weight W is attached in the string like this. The ball is pulled towards right side with a force Q. This is the position of the displaced position. The string makes an angle alpha with the horizontal like this, and this horizontal distance is. Now our interest is to find the value of alpha, Q and the tension in the string in the displaced position to maintain the equilibrium. Of course, if any system consisting of the string, the developed force is along the string and it is away from the point of observation. With this information, let us go to the solution of this problem. We are putting some names here. Let this point is B and let this point is C. The length of the rope is L. Let us try to discuss what are the various forces at the center of the ball. Of course, the first weight is W acting downwards. Q is the force acting towards right side, that is the pulling force. And S is the tension in the string along the string and it is away from the point A. Now let us transfer all these forces onto a separate XY plane for easy analysis. This is W, this is weight W, this is the pulling force Q and this is the tension in the string S. We know that S makes an angle alpha with the horizontal, hence this angle is also alpha. Now this distance, now look at this distance is given as D, and since this is the length of the string, hence B, this length is L. Now by considering the right angle triangle ABC, BC becomes root of L square minus D square from the Pythagoras rule. Now by considering the right angle triangle ABC, I can say cos alpha is equal to D by L or alpha is equal to cos inverse D by L. So we can say that cos alpha is equal to adjacent side, that is D by hypotenuse, that is D by L. Sin alpha is equal to root of L square minus D square by L. Like that, we can find the remaining all other trigonometric relations. Now, let us go to this free body diagram. There are three forces. All three forces are meeting at a particular point. So this is concurrent forces. And all three forces are divergent, so I can apply the sine rule. Now, according to the sine rule, the force divided by sine of angle between the other two forces is constant. That means W divided by sine of angle between the two forces S and Q. What is that? We know that this angle is 90 degrees and this angle is 90 minus alpha, hence the total angle S minus angle between S and Q is 90 plus 90 minus alpha, hence I can write the equation W by sine 180 minus alpha. Similarly, Q divided by angle between S and Q, this is 90 degrees, This is alpha, hence the angle between S and W is 90 plus alpha, hence I can write the expression Q divided by sine 90 plus alpha. That is equal to S divided by angle between W and Q, which is 90 degrees, hence I can write the expression S by sine 90. Now, we can take any two expression in order to solve the remaining problem. Let us simplify this. W by sine 180 minus alpha is equal to sine alpha. Q divided by sine 90 plus alpha is nothing but cos alpha, and sine 90 is equal to 1. Hence I can write this as W by sine alpha is equal to Q by cos alpha is equal to S. Now, by taking these two expressions, I can write S is equal to W by sine alpha, but sine alpha from this right angle triangle ABC, sine alpha is equal to root of L square minus D square by L. Upon substituting, I will get the equation S is equal to W by root of L square minus D square by L, or S is equal to WL by root of L square minus D square. Similarly, if you take another expression, these two, Q is equal to W into cos alpha by sin alpha, which is nothing but cot alpha. Q is equal to W into cot alpha. So from this right angle triangle ABC, cot alpha, what is the expression you can write? Cot alpha is equal to adjacent side D divided by the opposite side root of L square minus D square. Hence I can write the expression Q is equal to WD by root of L square minus D square. So these three are the answers. Cos alpha, alpha is equal to cos inverse D by L, S is equal to QL by root of L square minus D square, and Q is equal to W into D by root of L square minus D square. We can also solve this problem using method of resolutions. So this is the free body diagram of point A. Already we know that cos alpha is equal to D by L, and the remaining all other expressions sin alpha, etc., etc. Resolve all these forces along x-axis and y-axis. Q is horizontal, so need not to resolve. W is vertical, need not to resolve. But S is an inclined force which makes an angle alpha with the horizontal. Hence the horizontal component is cos alpha and the vertical component is sin alpha. Hence you can say the horizontal component is S cos alpha and the vertical component is S sin alpha. Now you can use your equilibrium equation sigma Fx is equal to 0. So I can say there are only two forces, both the forces are opposite, hence S cos alpha is equal to Q. But we know that cos alpha is equal to D by L, or S into D by L is equal to Q, or I can write S is equal to Q into L by D. This is one answer. The another one is sigma Fy is equal to 0. There are only two forces. These two forces must be equal. Hence I can write S into sin alpha is equal to W. Now S means Q into L by D, and sin alpha I can write the equation root of L square minus D square by L, and LL gets cancelled, and after simplification you will get Q is equal to W into D by root of L square minus D square.